Hybridization. Definition. Hybridization is defined as the process of intermixing of two or more different pure valence shell atomic orbitals of nearly equal energy within the same atom to produce same number of new orbitals having equal energy and identical shape which are symmetrically oriented in space before the formation of chemical bonds. The new orbitals so produced by hybridization are known as hybrid orbitals. Types of hybridization. Based on the types of orbitals involved in mixing, the hybridization can be classified as Sp, Sp2, Sp3, Sp3D, Sp3D2, Sp3D3. Let us now discuss the various types of hybridization, along with their examples. Sp hybridization. Sp hybridization is observed when one s and one p orbital in the same main shell of an atom mix to form two new equivalent orbitals. The new orbitals formed are called sp hybridized orbitals. It forms linear molecules with an angle of 180 degrees. Characteristics of sp hybridization. This type of hybridization involves the mixing of one s orbital and one p orbital of equal energy to give a new hybrid orbital known as an sp hybridized orbital. Sp hybridization is also called diagonal hybridization. Each sp hybridized orbital has an equal amount of s and p character, 50% s and 50% p character. Examples of sp hybridization. All compounds of beryllium like Bf2, Bh2, Bcl2 etc. All compounds of carbon containing triple bond like C2H2 etc. Here in figure we can see hybridization of Bcl2. Here we can see the mixing of one s orbital and one p orbital of equal energy to give a new hybrid orbital. Here bond angle is 180 degrees which is linear in structure. Sp2 hybridization. Sp2 hybridization is observed when one s and two p orbitals of the same shell of an atom mix to form three equivalent orbitals. The new orbitals formed are called sp2 hybrid orbitals. Characteristics of sp2 hybridization. Sp2 hybridization is also called trigonal hybridization. It involves mixing of one s orbital and two p orbitals of equal energy to give a new hybrid orbital known as sp2. A mixture of s and p orbital formed in trigonal symmetry and is maintained at 120 degrees. All the three hybrid orbitals remain in one plane and make an angle of 120 degrees with one another. Each of the hybrid orbitals formed has a 33.33% s character and 66.66% p character. The molecules in which the central atom is linked to three atoms and is sp2 hybridized have a triangular planar shape. Examples of sp2 hybridization. All the compounds of boron, like Bcl3, Bf3, Bh3 etc. are examples of sp2 hybridization. All the compounds of carbon containing a carbon-carbon double bond like ethylene, C2H4, is also an examples of sp2 hybridization. Here we can see the structure of Bcl3, which is sp2 hybridized compound. It is trigonal planar in structure. Here bond angle is 120 degrees. We can see in figure. Sp3 hybridization. When one s orbital and three p orbitals belonging to the same shell of an atom mix together to form four new equivalent orbital, the type of hybridization is called a tetrahedral hybridization or sp3. The new orbitals formed are called sp3 hybrid orbitals. Characteristics of sp3 hybridization. These are directed towards the four corners of a regular tetrahedron and make an angle of 109 degrees 28 minutes with one another. The angle between the sp3 hybrid orbitals is 109.28 degrees. Each sp3 hybrid orbital has 25% s character and 75% p character. Here we can see the sp3 hybridization in ethane, C2H6, and methane, CH4. Here bond angle is 109.6 degree. Bond length is 154 pm. Sp3D hybridization. Sp3D hybridization involves the mixing of one's orbital, 3p orbitals and 1d orbital to form 5 sp3D hybridized orbitals of equal energy. They have trigonal bipyramidal geometry. Characteristics of sp3D hybridization. The mixture of s, p, and d orbital forms trigonal bipyramidal symmetry. 3 hybrid orbitals lie in the horizontal plane inclined at an angle of 120 degrees to each other, known as the equatorial orbitals. The remaining 2 orbitals lie in the vertical plane at 90 degrees plane of the equatorial orbitals, known as axial orbitals. Here we can see sp3D hybridization in phosphorus pentachloride, PCl5. Here, we can see 3 hybrid orbitals lie in the horizontal plane inclined at an angle of 120 degrees to each other. The remaining 2 orbitals lie in the vertical plane at 90 degrees plane of the equatorial orbitals. Sp3D hybridization. Sp3D hybridization has 1s, 3p and 2d orbitals, that undergo intermixing to form 6 identical sp3D hybrid orbitals. These 6 orbitals are directed towards the corners of an octahedron. They are inclined at an angle of 90 degrees to one another. Here we can see octahedral structure of sulfur hexafluoride. Here we can see 6 orbitals are directed towards the corners of an octahedron and they are inclined at an angle of 90 degrees to one another.